Here is a little mystery before we start. If you type 1 divided by 4 into a calculator, it stops cleanly at 0.25. Hold that thought, because today it becomes mathematics. Welcome to Math Concepts Made Easy. Today is day 3, and our lesson is all about decimal expansions. Before we start, a quick recap. In our last lesson, day 2, we studied irrational numbers. What is an irrational number? Proof that root 2 is irrational. If any of that feels unclear, pause here and re-watch day 2 first, because today builds directly on it. By the end of this lesson, student can predict if a fraction terminates or recurs purely by analyzing its denominator, without using division. Grab a notebook, get comfortable, and let us begin. Before we touch any formulas, let me show you where this idea already lives in your everyday life. If you type 1 divided by 4 into a calculator, it stops cleanly at 0.25. But type 1 divided by 3, and it gives you 0.3333. Going on forever. Why does one stop perfectly, while the other refuses to end? You have been using this idea all along. Today we simply give it a name and learn its rules. So what is really going on here? The secret hides in how we count. Our entire number system is based on 10. And what makes the number 10? Just two prime numbers, 2 and 5. Therefore, if the bottom of a fraction is built using only 2's and 5's, it fits perfectly into our base 10 system and the decimal stops. If any other prime number sneaks into the bottom, it breaks the pattern, and the decimal loops forever. Keep that picture in your mind, because everything else in this lesson grows out of it. Now we are ready to say this precisely, the way mathematicians do. Here is our focus for today: terminating and non-terminating recurring decimals. In symbols, we write it as a fraction terminates only when its denominator is built entirely from 2's and 5's. Every word of that definition matters, so read it slowly. You already know rational numbers, prime factorization. This definition simply builds on those familiar ideas. Here is the key formula for decimal expansions. The formula is, a fraction terminates only when its denominator is built entirely from 2's and 5's. Watch how each part appears as I say it. Do not just memorize the symbols, make sure you understand what each one represents, because that is what the exam really tests. Let us put this to work with real examples, one step at a time. Test 3/8, 8 equals 2 times 2 times 2 equals 2 cubed, which means terminates 0.375. Test 7/25, 25 equals 5 times 5 equals 5 squared, which means terminates 0.28. Test 5/6, 6 equals 2 times 3, which means the 3 makes it recur, 0.833. Notice how every line follows logically from the one before it. That habit, checking each step, is what makes your answers reliable. Now, a quick warning, because I see students lose marks on this every single year. Before I show you, think about what could possibly go wrong here. 3, 2, 1. The ultimate trap is checking the denominator before simplifying the fraction. For example, looking at 6/15. The denominator is 15, which is 3 times 5. Because of the 3, students guess it repeats. But 6/15 simplifies to 2/5. The 3 cancels out. It actually terminates. Always simplify first. Compare the wrong way and the right way on screen, and promise yourself you will never fall for this one. Time to try it yourself. Here is your practice question. Does 6/15 terminate? Wait. Simplify first. 6/15 equals 2/5. Pause the video now, or take a few seconds with me. 5, 4, 3, 2, 1. Okay, let us solve it together. Denominator is 5. Yes, it terminates. How did you do? If you slipped anywhere, rewind and watch that step again. That is exactly how strong students learn. Let us bring today's lesson together in one picture. At the center of everything sits decimal expansions. We explored terminating and non-terminating recurring decimals. The one formula to remember is a fraction terminates only when its denominator is built entirely from 2s and 5s. Watch out for the common trap we discussed. And remember our goal: student can predict if a fraction terminates or recurs purely by analyzing its denominator, without using division. Next lesson, laws of exponents, all 6 laws with intuitive proof and examples. New lessons every day on math concepts made easy. Thank you for learning with me. See you tomorrow.